Welcome back to Basic Mathematics. In this video, we're going to be looking at the operations of multiplication and division, as well as powers and roots on fractional values. So without further ado, let me get my head out of the way and let's dive in. The rule for multiplying fractions is fairly straightforward. Of all of the operations on fractions, it is the easiest to work with. If you have two fractions, call them a over b and c over d, the rule for multiplying is to multiply directly across. A times c in the numerator and b times d in the denominator. That's it. That's all there is to it. So if I have something like 3 over 7 times 5 over 13, multiplying across, I have 3 times 5 in the numerator, and I have 7 times 13 in the denominator. 3 times 5 is 15. 7 times 13 is 91. So 3/7 times 5/13 is 15 over 91. If you want to call it a complication, the one thing we can do to complicate this process is to get ahead of ourselves. As you saw in the previous video, you always have to be careful and be aware that fractions need to be reduced in order to get a final result. One trick that you can use when you're multiplying fractions is to realize that multiplication is commutative. So if you have something like (3 over 7 times 5 over 9, the rules of multiplying say that we're going to write this out as 3 times 5 over 7 times 9, and we could do that multiplication if we would like. We get 15 over 63. But then we have to realize that 15 over 63 is a fraction that can be reduced because 15 divided by 3 and 63 divided by 3 work out evenly. This is 5 over 21. So the one trick that you should learn in multiplying fractions is that you can rearrange things. The commutative property of multiplication says that you can change the order of multiplication without changing the result. So 3 times 5 over 7 times 9 is the same thing as 3 times 5 over 9 times 7. And then we can break that up as 3 over 9 times 5 over 7. Why is this useful? Because it's a lot easier to reduce 3 over 9 than it is to reduce 15 over 63. With practice, you learn to do much of this in your head. I would go from this fraction all the way to here in one step without writing out those intermediate steps. And in fact, with enough practice, you can do this whole thing in your head without having to write down anything at all. But the trick is look for that early. If you have numbers you can reduce early, it saves you a lot of work later on. These numbers, this particular problem is not too bad. Consider something quite a bit nastier. 12 over 25 times 35 over 48. If you just follow the basic rule of multiplying fractions, you get 12 times 35, which is 420. You get 25 times 48, which is 1,200. And then you have to reduce. To get down to, looks like 7 over 20 at the end. It's doable. It's not necessarily difficult, but those are some ugly numbers, and it took some time to get all of that multiplication done. So again, if you follow a trick here and rewrite this and think about 12 over 48 and 35 over 25 as your fractions instead, just changing the order of those two denominators. Then 12 over 48, you can divide top and bottom by 12 and get 1/4. 35 over 25, you can divide top and bottom by 5 and get 7 over 5. So I make no claims that this is a shorter method. Even writing it out as efficiently as possible, it takes the same number of lines as going through the traditional process. The advantage is that each step, the arithmetic is so much easier in the process I did in yellow. So I strongly encourage you to practice playing around with fractions like that. It is a skill that will serve you well throughout your mathematics education. Now that we've got multiplication down, let's think about exponents. Exponents are pretty straightforward. If you want to square a number, that means multiply by itself. But what ends up happening is you square the numerator and square the denominator. In general, if you have a fraction a over b, and you raise it to some power n, you end up raising the numerator to that power and the denominator to that power. Furthermore, if the fraction you are raising to a power was reduced at the start, the result you end up with will never be able to be reduced. So take the time, double check that you're dealing with a reduced fraction when you start, and then this whole thing is easy. If I take something like 4/5 cubed, using that rule of thumb, 4/5 cubed is 4 cubed over 5 cubed. 4 cubed is 64, 5 cubed is 125. Because you cannot reduce 4/5, you cannot reduce 64 over 125. We don't even have to worry about looking for it. Right? So there is another nice extension on multiplication. Now that we can deal with multiplication and we can deal with exponents, that takes us to the inverses of those. The inverse of exponents is roots. The inverse of multiplication is division. I'm going to look at roots first because they are, again, fairly straightforward. Because when you square a fraction, you square the numerator and you square the denominator. If you want to take the square root of a fraction, it turns out that you take the square root of the numerator and the square root of the denominator. So the square root of 16 over 25 is 4/5. Just as with the exponents, if you start with a fraction that's already been reduced, you will never be able to reduce the resulting fraction. Although that's less of a concern when it comes to roots, it's usually faster to take the square root and then reduce it, because that lets you deal with smaller numbers. All right. But if I get that out of the way, we can take a look at dividing fractions. I've mentioned previously that in algebra, there is no such thing as division. And fractions are where that comes in. We don't define a way of dividing two fractions. Instead, what we define is a way of rewriting a division problem as a multiplication problem. You leave the first fraction alone, you take division and turn it into multiplication, and then you take the second fraction and you flip it upside down. Denominator becomes numerator, numerator becomes denominator. That process is called the reciprocal. And it's the key, it's the definition of division. So if we have something like 3/5 divided by 7/8, we leave the 3/5 alone. We rewrite division as multiplication, and we take the reciprocal of 7/8 to get 8/7. Now it's a multiplication problem, and we can solve the multiplication problem simply by multiplying across. We can check to see if anything reduces, and we always should. In this particular case, nothing does. So 3 times 8 is 24, and 5 times 7 is 35. 3/5 divided by 7/8 is 24 over 35. I have one last concept to talk about in this video, and that is the property of whole numbers. You know that if you take any number and divide by 1, you get that same number back. We can use that to our advantage. If you have a whole number, you can rewrite that whole number equivalently as that same value divided by 1. And because of this property, anytime you have a whole number, you can write it as a fraction. So if you're trying to multiply 2 times 3/5, we write it as 2 over 1 times 3 over 5, and then multiply across as normal. If you're trying to divide, you once again can write that whole number as a fraction and then use the rule of multiplying by a reciprocal to find that 3/5 divided by 2 is 3/10. And if you have mixed numbers that you're trying to do arithmetic on, if you're trying to do multiplication on, two and a half times 1⅓, you rewrite the mixed numbers as improper fractions. And I guess since we were given mixed numbers at the start, we should give our answer as a mixed number. 6 goes into 23 times. 3 times 6 is 18. Subtract that off, you get 2. So 20/6 is the same thing as, I'm running out of space here, 3 2/6. But that fraction reduces and can be written as 3 1/3. All right. With that, I'd like you to take some time now to practice multiplication, division, and powers on fractions. Once you're comfortable with all of the operations and all of the work we've been doing on those practice problems, there is a quiz on multiplying and dividing fractions to go through, and then one more video on problem solving and application and a couple of other messier things. So take some time to work through those practice problems, take the quiz, and then I'll see you in the next video.